Okay, AP Calc AB 2018, number 1, the escalator question. They give us the rate at which people enter a line, so that's the rate in. And notice that it goes to 0 after 300 seconds. And then keep reading, and they give us the rate out, or the rate at which they exit, 0.7 people per second. So we have a rate in and a rate out, and an initial amount. We start off with 20 people in the line. So part A, how many people enter the line? They give us the rate for their entering, so to find how many, it's an integral. So the number of people entering the line is the integral from 0 to 300. You could just write of r of t dt, but I wrote the whole thing out. Put it in the calculator, you get 270 people. Math 9. Okay. Part B. From 0 to 300, there are always people in line. So we want to know how many people are in line at time t equals 300. Well, part B, here's where we have to do how many were there to start with, plus how many entered the line, minus how many exited the line. And all this is plugging it into the calculator. We do all that, we get that there are 80 people in the line at time t equals 300. Now part C, when we're greater than 300, what's the first time that there are no people in the line? Well, we know at t equals 300 there are 80 people in the line. We want to know when there's nobody left. Well, there are no more people entering the line according to our piecewise function up there. So all we have to worry about is the rate at which people are leaving. And it's t minus 300 because now remember, we are talking about time over 300 seconds. So we say, okay, when does 80 equal the 0.7 times the t minus 300? And there we go. We get at 414.285 seconds. So that's our answer for part C. Part D, this is the typical one. I would say for this question, part C was the kind of different part, required you to think a little bit more because it was different from what they've asked before. But part D is the typical, when is the number of people in the line a minimum? Okay, so the minimum has to happen at the endpoints or when the rate entering equals the rate leaving. Calculator, just see where those two intersect. And they intersect at two different times, the 33.013298, which I define as A, and I stored in my calculator as A, or the 166.57472, which I store in my calculator as B. So now I don't have to write those values over again. And remember, if you're not going to use XSTOR alpha A, if you want to type in, because we have to do an integral, you cannot put in a rounded number. You have to type in the whole thing. So if we store it as A or B or whatever letter you want, it saves you from putting in wrong numbers in the calculator. And you cannot use just 33 or just 166 because your numbers will be off a little bit. So now I just do a little chart where I have, in this case, my 4 different times, and then the number of people, and I write my equation for how I'm determining the number of people. How many we start with, plus the number that enter, minus the number that exit. Now, just be careful when I write the integral. T is the upper bound, because we're going from 0 to whatever time t in our chart, and you put some dummy variable in there. I'm just using x, and that's for both integrals. And there are the results from the calculator. Question wants to know at what time is the number of people aligned in a minimum, and then what the number of people is to the nearest whole number. So we can see from the chart, the time is time A, which is 33.013. Now we can round it because we're answering the question. And number of people to the nearest whole number is 4. So on this question, it's a pretty typical question. Again, we'll know tomorrow. Hopefully we'll have a little better idea of what this test is going to look like. Do I necessarily think they're going to put one on there like this? They might, but I don't know. I'm not too convinced there's going to be one of these on there. But the max and min part, I think, is the part we have to pay the most attention to and make sure we understand that we have to take into account the endpoints and any point in between where the rate entering equals the rate leaving. Okay.